Hey guys, welcome to the first day walkthrough for the physics test, okay? So basically for the third question, so that's the one of the circular motion, I have the mark schedule here with me, but I actually couldn't find any of the questions. I have the mark schedule, but I don't have the question, okay? So basically I'm just gonna give you like an approximation, okay? So question 1, okay, there's a circle basically. Okay, so there was like these seats here, okay. So basically what I want, okay, actually this is better. This is not my crappy drawing. So basically you had the circle here, okay. So basically there was an object, okay, let's just say there's an object here, and that was the seat. Oh no, the seat was inside the circle, sorry. The seat is inside the circle, so this is the seat here. And therefore there's it's asking you to label the direction of the velocity and the direction of the centripetal force, okay? Direction of the velocity always acts 90 degrees to the center of the circle, okay? And because it says that it's moving clockwise, therefore the velocity acts in this direction, and then the centripetal force acts towards the center, okay? So that's just 90 degrees and acts towards the center. You would label that FC. Okay, so FC acts towards the center and V acts 90 degrees to the center of the circle. Getting both these vectors correct, both labels, gets you a merit grade actually. And to get achieved, it's either one of these labeled correctly. So either will get you an achieved. Okay. Alright, next question. It asks you for the calculation. So what is centripetal force? Okay, so it told you that the mass of the, I think it was John. Correct me on that, but apparently John was 80 kilograms. Okay, and then it gave you that the radius of the round was equal to 2.66 meters, and the period, so the time to make one complete rotation was 3.2 seconds. Okay, and then wanted you to find the FC. So you wanted you to find FC. So basically in this question, okay, the first thing you have to do, you need to find speed, okay? So Fc equals to mv squared divided by r. You actually don't know what velocity is, okay? So you have to find velocity first, okay? So you know velocity equals to 2 pi r over t, okay? And you know that r is 2.66 and t is 3.2, and 2 pi is a constant, so you'll be able to work it out. So v equals to 2 pi 2.66 divided by 3.2. You plug that into a calculator, you should have got v equals to 5.22 meters per second. Now we have the velocity, we can plug it into the FC formula, okay? We'll say FC equals to mass, okay? So mass of John is 80 kilograms multiplied by 5.22 whole squared divided by the radius, which is 2.66. If you plug that into your calculator, okay, you should have got somewhere 819.5. So you should have got FC equals to 819.5 newtons. Okay, that should be your final answer right here. And getting all the way to the correct answer will get you an excellence grade. Getting the merit grade is correct working but incorrect answer, okay? So I don't know how that's going to be judged. So basically if you get all the working is correct, but you made like a slight calculation mistake, you'll get a merit grade, okay? And to get it achieved, any attempt at the correct answer which shows valid understanding. So what it means by valid understanding is maybe you know what the FC formula is. You can know what you found the velocity maybe, that shows understanding. That might get you an achieved. Alright, so the next question, okay. It told you that why is John accelerating even though he is moving at a constant speed, okay? So I'm not gonna write everything. I'm not gonna write it down, okay? But I'm just gonna explain it to you, like what it means, okay? So I'm gonna jot down some bullet points, okay? So bullet points, okay? Vector is vector quantity. Not vector is vector quantity. That's so funny. Velocity is vector quantity. So velocity is a vector quantity, magnitude and direction. Okay, so velocity is a vector quantity. It has both magnitude and direction, okay? So then you got to link that to speed constant. Speed is constant, direction is changing though. Okay, because the direction is changing, okay, the direction is changing and velocity is a vector quantity, we can say velocity is changing. And this can only be done if there's an unbalanced force, okay? So the unbalanced force, centripetal force. So you have to link it back to centripetal force, okay? And then you link it back to Newton's law of F equals ma. Because there is an unbalanced force, okay? Because there's an unbalanced force and John has a mass, therefore there has to be an acceleration, okay? So that's one way to explain it. Another way to explain it, you can say that the acceleration is defined as the rate of change of the velocity, and because the velocity is constantly changing, because it's always changing direction, so therefore the velocity is constantly changing, and because the acceleration is defined as the rate of change of velocity, therefore there is a certain acceleration. So therefore so yeah, that's basically it, okay? But this question, okay, I'm looking at the mark schedule right now, okay? So this question is a bit stingy, okay? So it says you can get a merit grade for this question, but you must link it to the definition of acceleration. So you have to say that the acceleration is defined as the rate of change of velocity. You have to say that. So you have to say, quote unquote, the acceleration is defined as the change of velocity. If you don't have this, line in your answer, that you can't get the merit grade, which is, in my opinion, that's a bit stingy, but I can't change the mark schedule. So to get a merit grade, you're linking all the points together, but you have to say that acceleration is defined as the rate of change in velocity, okay? Because the velocity is changing, John is to be accelerating, okay? That's to get the merit. To get an achieved, you're stating that the velocity is changing due to the changing direction. So saying that direction is changing, and therefore it is accelerating. That will get you an achieved. Alright? Yeah, so I know that that's a bit stingy of the question to make you do that, but I can't do anything about it. So you have to make the link to the definition of the acceleration. Alright, so the last question, question D, is actually only an achieved question. So all you have to say for question D is that his phone will move in the direction tangent to the circle, to the middle of the circle, okay? That's all you have to say. So here's what it says on the mark schedule. It says, his phone will move in a direction tangential to the circular path. That'll get you an achieved grade. So this question, it made it look like it was an excellence question, but it was actually only an achieved question. Yeah, so all you have to say is his phone will move in a direction tangential to the circular path. Yeah. And that'll get you an achieved grade, okay? So if you did all these explanations, that's fine, but it's a shame that it's only an achieved question. So again, I can't do anything about it. The wording of the question was not very good. It seemed like they wanted a lot of detail, but it says here on the mark schedule that it's only an achieved question. You know the very last question? Yeah, that's only an achieved question, so can't do anything about that. But thank you for watching the video. Hope you enjoyed, okay? You see, I was gonna explain more, but I don't really have time. I have to go to tennis right now, so I don't have time to explain the last question in depth. But all you need to get the achieved grade is his phone will move in a direction tangential to the circular path, okay? That's all you need to get the achieved grade. Alright, so thank you for watching this video. I hope you enjoyed, okay? If you have any questions, please leave it down in the comments below, okay? And that's me, okay? I'll make a video about the very last question later today when I get back. So you can probably expect a video at around maybe 9:30ish, maybe 10 o'clock. I'll post a video about the very first question. But for now, peace out. Thank you.